Great Lakes Aquarium, and today I am in our Global Connections exhibit, and we are going to be talking a little bit more about climate change, but specifically the effects we see on the ocean. But to start off, because climate change can be kind of a heavy topic, I have a joke for you. What stresses corals out? Current events. It's kind of a joke because it's funny, but also it's kind of real. Current events like climate change can actually stress corals out. And that's exactly what we're going to be showing today. We have an experiment here to do, and we're going to talk about how these gases in the atmosphere, so that CO2, like we've mentioned a couple times this week, interact with the water of the ocean and then impact what's going on to that biome down there, or all of that life. So, looking over here, I have all of my stuff ready to go. I do want to be mindful of safety, so I have my goggles and my gloves. And what we're going to do is I have these two cups over here. And I'll show you a little bit of what I have in here. So over here is a mixture of bromothymol mixed with water. So I mixed that up earlier and I sorted it out into two different cups. Then I took some baking soda and I have it in this little cup here. And I'm actually going to take that inside one of my cups. Just like so. I'm going to have it right near the water or the mixture. We're not touching it like that. Hopefully you can see it at home. Connect that. There we go. Now, you might have done this type of experiment before, taking baking soda and vinegar, and it makes it explode. So our goal today isn't to make it explode, but instead just release those gases, that CO2. So I have some pipettes here full of vinegar. So I'm going to put the vinegar in with the baking soda, but you can notice that it's not mixing with my bottom solution here. So instead, we're just going to let the gas interact down here. So, I'm going to go on in. I want to make sure I have the right amount of vinegar. Put that in, and then I'm going to cover it with my lid and time it for a little bit. Alright, so the lid is helping keep the gases in my container, and we're going to be watching to see that interaction that happens. So bromothymol is actually a pH indicator. So pH lets us know if something is basic or acidic. So when things go to the acidic side, we're going to see some color change going on. I think there's already some going on right here. Can you see it at home, I hope? Nice. Man, science is so cool. So it's changing colors and it's starting at the surface and starting to work its way down. Wicked. Now, as cool as this is, the real life implications can actually be pretty serious. So over here on our wonderful whiteboard that you've seen a couple of times, we have carbon dioxide here at the top, and we have the ocean. Now, just like what we talked about earlier this week as well, big bodies of water are really great at sucking in heat, but also absorbing a lot of that CO2. So our oceans will absorb about 90% of the excess heat that we're seeing through climate change. And then, it also will absorb about 25% of that CO2. So if we see increasing temperatures and increasing CO2, that's increasing the amount of heat and CO2, or carbon dioxide, that's going into the oceans. The results of that will be sea level rise. So melting glaciers are adding more water, it's changing up ecosystems, and that sea level is coming up, which has a huge implication on us living on the coast or things like that. So we're seeing that. We're seeing bleaching happening, especially with our corals. We'll talk a little bit more about that in a little bit. Toxic algae blooms. So you might have heard recently there was one out on Lake Superior, And that can be really, really harmful. So when we have not only raising temperatures, but excess nutrients from pollutants that are in our river systems going into big bodies of water, we'll see those toxic algae blooms increase, not only just in number, but size. One other thing that we see when these oceans are dealing with climate change is lowered oxygen. So just like we need oxygen to breathe here on the surface, these animals in the water also need oxygen to breathe. So when we see less oxygen in the water, some of these animals are going to start suffocating by the little bit of oxygen that's left. And then just like we saw in our experiment, acidification. So that CO2, we go back on over to the experiment. We'll look at it right now. We see some major color change. So that means that this solution is turning more acidic. So as it's turning more acidic, that can make things a little bit more dangerous, especially if organisms in the water aren't able to adapt as fast as they need to. And what it's putting out in here is actually carbonic acid. And so this is interacting with corals, with shells that need to calcify. So if you think of clams and oysters, those types of animals, they need all of that calcium in order to build their shells. When the oceans get more acidic, it can break those down, but also reduce the amount of necessary kind of ingredients they need to build those shells. So this is a pretty big deal. So we can see from the gases, it was interacting with the surface and then going into the rest of the water. The last thing that this impacts is the food web distribution. So, when we think of food webs, we know that animals eat other animals, they eat plankton, they eat plants, so everything has a role in the food web, including us. We're a part of this worldwide food web. And most of the population of the world eat a ton of food that comes from our oceans and our other body waters. So if we see a disruption in that food web, so if we're not seeing as many clams, for instance, and things that eat the clams, then they don't have enough food. And they start to die off. And then the things that eat those animals, they start to die off because they don't have enough food. Ultimately, that's going to reach to us. And when we see all of these changes happening all together, that's a lot of change to a lot of species, creating massive disruptions in that food web. So it's really important to think about how the effects of climate change really impact our oceans and us. Because even though the oceans are far away, they still are going to have implications here in Minnesota. So it's always good to think about that. Over here, in our Global Connections exhibit, we have some beautiful examples of these corals. Now, I had mentioned coral bleaching. So coral bleaching happens when temperatures rise in the oceans. Even just a rise of about 2 degrees can start bleaching these corals. And what that means is that in these corals is algae. And that algae will get expelled from the coral if it gets too warm. So when that happens, the corals lose their color, which is what we get the term bleaching from. They turn white, but also the coral and the algae have a really great relationship. So when they're there, the coral provide a home for the algae. When that algae leaves, the things that they bring to the coral include food through photosynthesis, as well as oxygen through photosynthesis. So ultimately, a coral can survive for a little bit without that algae, but if it's gone for too long, it's not a good situation, and we see higher mortality or higher deaths of those corals. So, this is a lot of doom and gloom. I realize that. Climate change is a pretty scary thing. But if we have the mindset that we can still make change in a positive way, it kind of takes a little bit of that doom and gloom away. Yes, these are really serious problems with really serious implications, but there are things you can do every single day to help slow the amount of change that we're seeing in the climate. We can reduce, reuse, recycle. That's such an easy one to do, the 3 R's. We can start looking into renewable resources. Very easy as well. Well, I guess I shouldn't say very easy. That one can be kind of complicated. But by talking about it and getting that word out there and sharing information of what's going on, we can start making changes at community, country, and global size. So it's really important to get that conversation going, especially about renewable energy. We can start greening up our commutes. So biking, walking, public transportation, all good ways to green your commute. Even carpooling if you are working from far away. And then also things like eating local. So reducing how far our food is traveling from where it's being made to getting to us. Very easy way. Starting a garden. Things like that. Things we can do every single day. That if all of us start making a couple of those changes every time, we're going to see less impacts in the long run. This stuff is happening. It's happening right now. But we can start making a difference on the rate of which some of these are happening. And that's what's important. That's the amount of hope that we should be hanging on to. And that's what we should be thinking about when we're swarmed with all this doom and gloom. We can still make change, and we can still make positive change that will ultimately make a huge difference. Let's go on back to the experiment to see where we're at now. Whoa, it's almost completely yellow now. Pretty amazing. Now, if you want to do an experiment like this at home, it can be pretty simple. I realize not everyone can have certain solutions at home, but what you can do is take purple cabbage and boil it. Boil it down so the water is nice and purple, and then strain out any of the cabbage. Take that solution and dilute it with water. And what we can do, I'm going to take my control here so we can see. With every experiment, you want to have a control so you can see where you started and where no change happens. And then an easy way, you can either go this way with the baking soda and vinegar, which is super cool, or just by taking a straw, you can put it into the pH solution and there we go. It has changed colors based on the pH in the solution from the carbon dioxide that I'm expelling through breathing. Pretty neat. And this is something you could totally do at home. So with that, I hope you learned a little bit about the major changes that we're seeing in our oceans, how they can impact us, and ways that you can make a difference. Thank you again for watching. We really appreciate all the support we've gotten through watching these videos, sharing them, liking them, commenting on them, but also donations, buying things from our Redbubble sites. So I have my coffee and my trout mug. All of that information is right on our website. I put the link in the description so you can go check it out. So many ways you can help Great Lakes Aquarium. Again, we are so appreciative of all the help we've gotten. And I hope that this video was not super scary. That's never the goal. But gives us hope for ways that we can make a positive impact for the future. So with that, thanks again for filling in. Joining us? I think so. And happy Friday. Enjoy your weekend. We'll be back next Tuesday at 1 o'clock for another live. We're going to take a break from Memorial Day. But then we'll be back with some great videos talking about some more amazing things that you can learn here at Great Lakes